Logarithms. Function composition. According to the Merriam-Webster dictionary, the first definition of the word compose is to form by putting together. Here we are going to learn what it means to compose functions. One way of thinking about it is that we are going to use one function as the input for another function. Because there are two different ways to represent function composition, it can be difficult to remember what the two representations mean. So suppose that we have two functions, f and g. If we are interested in the result of f composed with g, we can represent this as f of g of x, or f composed with g of x. So this is just a little circle there in between the two. It looks a little like fog, but it is not. That is a function composition symbol. To find f of g of x, we use the entire function g as the input of f, and then simplify. Let's compose two linear functions in example 1. So here we're given those two functions, f and g. Whoops, I split it apart here. I'll try to fix that in yours. So notice that I wrote it in the function composition notation here. And so what that looks like is this. I'm going to highlight g of x as green, and I'm going to highlight f of x as red. So the way it's going to look like is this. F of g of x will equal, so the f, we have 2 times x, but x is the entire function g. So the input for f is the entire function g of x. Negative 4x plus 1. So notice right here where the x was in our function f, we plugged in our entire function g. Now we need to finish f, which is plus 3. So now we are going to distribute that 2. All right. So we'll get, so this is going to equal negative 8x plus 2 plus 3. So 2 times negative 4x, that's a negative 8x. 2 times the 1 is positive 2, and then we have plus 3. Now we can combine like terms. We have negative 8x plus 5. So f composed with g is equal to negative 8x plus 5. Or said another way, f of g of x is equal to negative 8x plus 5. It's important to notice that the order of the composition matters. Example 2 uses the same two functions as example 1, but the outcome is different. So let's have a look and just verify that it really is different. So I'm going to have to make this kind of small here, sorry. So we're going to do g of f of x. So that's going to equal, g is negative 4 times x, and there x is going to be f, so that's going to be 2x plus 3. And then we need to finish off g, which is plus 1. Now we can distribute that negative 4. Negative 4 times 2x is negative 8x. Negative 4 times 3 is negative 12 plus 1. So we have negative 8x minus 11. So notice that these two functions are, in fact, different. And that's really important to see. All right. Like normal functions, we can evaluate composited functions or composite functions, really. That shouldn't be there. We can evaluate composite functions, and that's example 3. So we're going to use those same two functions, and we're going to do g of f of 5. So evaluating means that instead of x, we have a number. So g of f of x. So notice that there are a couple ways of doing this. You can use the result of g of f of x and just plug in 5. That's one way of doing it. The other way is to first do f of 5 and then use that outcome as the input for g. And we'll do it that way. All right, so f of 5 is going to be 2x plus 3. So f of 5 will equal 2 times 5 plus 3, which is 10, plus 3, which is 13. So f of 5 equals 13. So I can replace this f of 5 with 13, and what I get is g of 13. And g is negative 4x plus 1. And so we'll have negative 4 times 13, that's negative 52, plus 1 is negative 51. So that tells me that g of f of 5 equals negative 51. All right. So possibly the most important feature of function composition is how it relates to inverse functions. When a function is composed with its inverse, regardless of the order, the result will always be x. Due to this important outcome, we can check whether two functions are inverses by composing them. And this says examples 4 and 5, but we're just going to do one example here. And this should say 4. Wow, lots of things to fix here. All right, so we're going to compose this as f of g of x. And I'll highlight these. We'll do g is green and f is red. All right. So that's going to equal 2 times the quantity, and g is the input for f. So for x right here, we're going to put all of g. So it's going to be x minus 3 over 2. And now we have this plus 3 right there. All right. So we need to distribute that. Well, we don't need to distribute. We can just see that when we multiply 2 times this fraction, those 2's make a 1. So the result there will be the quantity x minus 3 plus 3. So this makes a 1, and we're just left with this x minus 3 inside the parentheses. But x minus 3 plus 3 is just equal to x. And if we compose that the other way and did g of f of x, so opposite of that, we would also get x. Really, you're supposed to compose it both ways, but it's only really necessary in certain kinds of functions, and I'm not going to focus on that in this video. And that is logarithms function composition.